Hi there, welcome to my channel Maths SL. I'm speaking Thaqib Latif. I'm going to show you trial exam September last year 2024. The question says optimization question about the cone. The question says the flower pot below is in the shape of a cone. R is the radius of the base and H is the perpendicular height of the cone. The slant height of the cone is 12 centimeter. So must remember the slant height is 12 centimeter. This is the slant height 12 centimeter, and they provide the formulae for volume. All of these formulae they already give it to you. 10.1 says show that the volume of the water needed to fill the entire flower pot can be expressed as volume is equal to 48 pi h minus 1 over 3 pi h cube. So I'm gonna use the Pythagoras here because the radius on right hand side, which I also highlighted with the red color, and with the yellow color I indicate that is also 90 degree. So I got the information on right hand side, that's why I'm gonna utilize this side. So uh, so the radius, I'm gonna apply the Pythagoras here. So I'm gonna find the radius. So the slant height is 12. So the 12 r square is equal to 12 square minus h square. I'm going to apply the Pythagoras. First I will find the r, then I'm going to find the volume of cone, which is I'm going to use the formula 1 over 3 pi r square h. Sorry for that, my camera was off. I realized now. Let me show you what I have done here. So I'm going to apply the Pythagoras here. R square is going to be equal to 12 square minus h square. So I simplify, this is my r square, and the volume of the cone is 1 over 3 pi r square h. So place of r square, I substitute 144 minus h square. Now I'm going to simplify. So I'm going to use the calculator. 1 over 3 pi multiply 144 is going to be 48 pi. And obviously I have to multiply h also. So it's going to be h. And then minus 1 over 3. Again I'm going to multiply. This become h cube 1 over 3 pi h cube. Just remember I have to multiply 1 over 3 pi as well h also. So 1 over 3 pi h cube. So this is going to be my volume of the cone, and that I need to prove according to the question. So I proved. So therefore, so this is my volume of the cone. Now second part of the question. The second question says the gardener wants to maximize the volume of water in the flower pot. Determine the value of h for which the volume is a maximum. So you're looking at maximum value of h. So second part of the question 9.2, I need to find the maximum value of h. So obviously I need to find the first derivative must be equal to 0, and then I will solve for h, and then I will find the answer. Have a look here. So I'm going to apply the derivative here. So it's going to be a dv over dh must be equal to 0. So I'm gonna differentiate with respect to h. This is my function. So it's gonna be I'm gonna apply derivative here. It's gonna be 48 pi, because so the derivative of h is gonna be 1. Now minus this 3 multiply 1 over 3 is only gonna be a 1. So it's gonna be a pi, and 3 minus 1 is 2. So h power 2 is equal to 0. So this I apply the derivative. Now I need to solve for h. So minus pi h square is equal to, this become minus 48 pi Minus and minus cancel. I need to find the h square. So the 48 pi divide by pi, and pi cancel, so only left 48. So therefore h is going to be a 48 square root, positive and negative. Now h, I'm going to use the calculator. So answer is plus minus 6.93. I round off till 2 decimal place. Now I need to see, must I take the positive value or the negative value? So I need to apply the second derivative test. So I'm going to apply the second derivative test, and I'm going to differentiate with respect to h. So it's going to be this constant is going to be a 0, and this become 2 pi and h. 2 pi h, 2 minus 1 is 1. So this is my second derivative, negative 2 pi h. Now I need to substitute positive 6.93 into this equation. Positive 6.93, I substitute place of h, so the answer is negative 13.86 pi, which is less than 0, which means is negative. So it's a maximum point. It's a maximum point. So therefore I'm going to use the positive h value, because we need to find the maximum value of h. So it's going to be a 6.93. This is my final answer. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.